Section 8.6, Natural Logarithms. Exponential functions have inverses. Likewise, the function y equals e to the x, where e is approximately 2.71828. We've seen this function before, and we know that this is an irrational number very similar to pi. And that has an inverse, and that inverse is denoted as ln y equals x. In other words, it's called the natural logarithm function. We do pronounce this as ln y equals x. Here's the natural logarithmic function. If y equals e to the x, then the log with base e of y equals x. That's how that would be denoted in log form, which is commonly written as ln y equals x. The natural logarithm function is the inverse, written as y equals ln x. Therefore, we have the exponential function, y equals e to the x, and we have its inverse, which is y equals ln x. And you can see it is reflected over our identity function, y equals x. Let's take a look at our first example. The properties of logarithms all apply with natural logarithms. Therefore, here I'm going to have ln 3 to the 4th power plus ln 10 to the 2nd power. That's the power rule. Then I can simplify each natural logarithm. So I'm going to have ln 3 to the 4th power is going to give me 81 plus ln 10 squared is 100. And the sum tells me that I can use the product rule. Therefore, this will give me ln 81 times 100 is 8100. Next, again, the power rule, I can have this written as ln 2 cubed minus ln 4 squared. Simplify each logarithm is going to give me ln 2 cubed is 8 minus ln 4 squared is 16. The quotient rule can apply because of the minus sign. It gives me ln of 8 over 16, which will give me ln of a half. Again, I want to write these expressions as a single natural logarithm. Here I'm going to have 2/3 ln x minus 2 ln y plus 3 ln z. Let's use the power rule to simplify. That's going to give me ln x to the 2/3 power, which is going to be the cube root of x squared, minus ln of y squared plus ln of z cubed. Let's perform the quotient property. That's going to give me ln of the cube root of x squared over y squared plus ln of z cubed. I'm going to simplify again, since the addition tells me this is the product rule. That's going to give me ln of z cubed times the cube root of x squared all over y squared. On this example, I have 3/4 ln x plus ln y minus 2 ln z. Let's simplify inside our parentheses and use the power rule, and use the power rule here also. So that will give me ln of x y to the 3/4 power minus ln of z squared. 3/4 has to be taken to each one of these terms inside my parentheses. So that'll be x to the 3/4 power and y to the 3/4 power. In other words, we can write that as ln of the 4th root of x cubed y cubed minus ln of z squared. Now I can use the quotient property, which will give me ln of the 4th root of x cubed y cubed over z squared. On this example, I want to find the value of y for the given value of x. There's two ways that we can do this. One, we can substitute directly into our equation. Therefore, that will give me y equals 0.8 minus 5 ln of 0.12. Then I can just plug that into a calculator. And when I do, that's going to give me 0.8 minus 5 ln, and I'm going to substitute in 0.12 for x. Press enter, and I get a value of 11.4013. Now what I could do is use some properties of logarithms to simplify this a little bit further. And that will give me y equals 0.8 minus, and that would be ln x to the 5th. I can't use the quotient rule because that's not a log, so that doesn't work. So I have to keep that 0.8 minus ln x to the 5th. Using a calculator gives me 0.8 minus ln, and that will give me 0.12 when I substitute in for x, and that will raise to the 5th power. And when I do, I'm going to get, notice, the same exact solution. So y equals 0.8 minus ln 0.12 to the 5th power, and I still get y equals 11.4013. Just follow your properties of logarithms and substitute into the calculator, and the values will work out the same. In this example, I want to solve natural log equations and check your answer. We're going to follow the same procedure as we did in the last section when we solved log equations. Therefore, I have the natural log of 3x plus 5 equals 12. I want to write this in exponential form. That gives me 3x plus 5. And here our base in the natural log is e. So this is e to the 12th. Subtract 5 gives me 3x equals e to the 12th minus 5. And then divide by 3 gives me x equal to e to the 12th minus 5 over 3. I can plug that value into a calculator. I have e to the 12th. I get an answer, subtract 5, and then divide that solution by 3, and I get a value of x equal to 54,249.9305. Now, I want to plug that back into my equation to make sure that solution works out. So I'm going to have 3 times 54,249.9305. I'm going to hit enter. I'm going to add 5. And then I want the natural log of that solution. That gives me 12. Therefore, this is my solution. In this example, I have the natural log of 2x minus 3 quantity squared equals 8. Let's write that in exponential form. That's going to give me 2x minus 3 squared equals e to the 8th. That will give me 2x minus 3 squared equals e to the 8th is approximately 2,980.958. Let's take the square root of both sides. That's going to give me 2x minus 3 equals plus or minus 54.5982. That will set up 2 equations. The first one is going to be 2x minus 3 equals a positive 54.5982. 2x, after adding 3, is going to be 57.5 2982. Divide by 2, x is going to equal 28.7991. My next equation is going to be 2x minus 3 equals a negative 54.592. I'm going to add 3, and 2x will equal a negative 51.5982. Divide by 2, and I get x equal to a negative 25.791. If I substitute both values back into this equation, 2 times 28.7991, get an answer. Subtract 3, get an answer. Square it, get a solution. And then take the natural log of that, I get approximately 8. Similarly, when I take 2 times a negative 25.7991, get a solution. Subtract 3, get that solution. Square it, get that solution. Take the natural log. Again, I get approximately 8. Therefore, these two values are both solutions to this equation. On my next equation, I have 4 ln 3x squared equals 6. I'm going to divide by 4 first, since 4 is multiplying my natural log. That's going to give me ln 3x squared equals 6 divided by 4, and when I simplify, is going to give me 3/2. Now I'm going to write this in exponential form. That's going to give me 3x squared equals e to the 3/2. Find the value for e to the 3/2. That's going to give me 3x squared equals 4.4817. Divide by 3, and I'm going to get x squared is equal to 1.4939. Take the square root of both sides. I get x equal to plus or minus 1.2223. And when I plug both those back into my equation and then plug into a calculator, I get each to be a solution. Therefore, plus or minus 1.2223. My next equation, ln x equals a negative 3. Let's just write this in exponential form. That's going to give me x equal to e to the negative 3. Plug that into a calculator, and I get x to equal 0.0498. Substitute that value back in to find the ln of 0.0498, and I get a negative 3. Therefore, this is my solution. I have 1/2 ln x plus ln 5 minus ln 2 equals 5. I want to solve this equation for x. Let's condense this side under one logarithm. That will give me ln 1/2 by the power rule is going to give me the square root of x. Plus 5 means I can use the product rule. It gives me 5 square roots of x. Minus ln of 2 means the quotient rule, which is dividing by 2, equals 5. Write that in exponential form, gives me 5 square roots of x over 2 equals e to the 5th. Then I calculate the value of e to the 5th. That's going to give me 5 square roots of x over 2 equals 148.4132. I'm going to multiply by 2/5 on both sides. That gives me the square root of x equal to 59.3653. Then I square both sides to solve for x, and x is approximately 3,524.2345. And when I substitute back into the original equation, it does work out. Therefore, that is my solution. Here I want to use natural logarithms to solve each equation. We've done this in the past with common logs. Now we're just going to use it with natural logs. Here I have e to the x equals 12. What I'm going to do is write this as a natural logarithm. That's going to give me ln of 12 equals x. Now I can plug that into my calculator, and I get ln of 12 to be 2.4849. Therefore, x is equal to 2.4849. In this equation, I have 5e to the x over 5 minus 2 equals 12. Let's add 2 to both sides. That's going to give me 5e to the x over 5 equals 14. Divide by 5. E to the x over 5 equals 14/5. Let's write that as a natural log. Therefore, that's going to give me ln of 14/5 equals x over 5. Multiply both sides by 5. X will equal 5 ln of 14/5. And when I plug that into a calculator, I get an approximation for x to be 5.1481. I plugged that back in and used the calculator and verified that that does equal 12. Therefore, that is my solution. In my last example, I have 7e to the 2x plus 3 equals 42. I'm going to divide both sides by 7. That gives me e to the 2x plus 3 equals 6. Now I'm going to write that as a natural log. That's going to give me ln of 6 equal to 2x plus 3. And I'm going to approximate ln of 6 to be 2x plus 3 equal to 1.7918. I'm going to subtract 3. That's going to give me 2x equal to a negative 1.2082. Divide by 2. I get x approximately equals a negative 0.6041. And I did plug that back in to verify, so that is my solution.